We have just installed solar panels on this property behind me, which is only 2 months old. Do you think it passed its structural survey? Watch this video to find out. Hey, welcome back to another Alps Electrical installation video, and I'm here in Middlesbrough. I'm stood in the back garden of a brand spanking new house. This house has literally only been up a matter of weeks. I have houses 3 doors that way that are just half built. And we were here a few weeks ago, as soon as the customer moved in, within a couple of days, to install all the solar panels. And the reason being is they wanted to crack on with it. They want to get everything up and running as soon as possible. So all the background work that we did before they'd even moved in. We had a few meetings on site. We came along and we designed the system. We applied for the G99 before they'd even got the keys. And as soon as we got the keys, we came along and installed the system. The only issue we had was that the Tesla Powerwall wasn't available. Because some selfish national company decided to reserve all the Powerwalls that were available in the UK at the time, only to then cancel the order towards the end of the month, which meant that we eventually could get one. But at the time, the customer really wanted to get on with the installation, wanted to at least get the solar panels on before the neighbours moved in, because we had to put some scaffold in the neighbour's garden. So obviously you don't want to start off on a bad foot, do you, with your brand new neighbours. So we did all the paneling a couple of weeks ago and set the system up ready for the Powerwall. So what it meant was we had to install the system, bearing in mind what we're going to have to do when we come back with the Powerwall, because the system currently is supplied from the main consumer unit. But now, today, we're going to change that, and obviously we're going to put the gateway in, the Tesla gateway, and that's where the main incomer will go in and then back out to the consumer unit, but the gateway will be feeding the inverter. And we've also got some manipulating to do with the EV charger, because we installed a My Energy Zappi while we were here as well, and the customer already had an existing EV that was installed by the builders. So we're going to put both of them chargers into a new small consumer unit. I've done other videos on this where we install the system so that the solar cannot see the EV chargers, because we don't want the EV to pull from the battery. And indeed, we don't want the EV to take the solar generation, because you can get paid 15 pence on Octopus Intelligent Go for your export. So you don't want to be using that to fill your car when you can use the 7 pence on a night to fill your car. So we're going to set up a separate consumer unit here to supply the two EVs. And then the gateway will supply the inverter, and obviously it supplies the off-grid power in the event of a power cut as well. This customer has a 5.28 kilowatt system consisting of 12 440 watt JA solar panels, and then they've got a SolarEdge 5 kilowatt inverter. And of course, with SolarEdge, guys, it is the creme de la creme. Every single solar panel has a SolarEdge optimizer underneath it, so that you can actually monitor what every single panel's doing individually, and of course optimize them as well, so they are as efficient as they could possibly be. One panel is not going to affect the other, and that was important on this job, because we've got a roof on the side there that is actually a good south facing roof that we wanted to utilize, and you could only fit 2 panels on it. So that on its own wouldn't work on its own string, so it needed optimizers. So that's why we've gone with optimizers on this job. So if I just go into their SolarEdge app here, guys, I can show you the site mapper, which is pretty cool. Look at the day. It's not a very nice day today, 0.26. It's very cloudy. But if I go into here, we can see the physical layout. There's all the panels, and you can zoom in and you can see what every single panel is doing individually, what it's producing. You know, so there might be a little bit of cloud cover, more cloud cover over this one, 5.5, whereas the 8.75 there, that's producing a little bit more. But yeah, that's the full layout of the panels, and how you do that is by every single optimizer has a little barcode on it, so you set them barcodes out. I just put them on a bit of paper in the order that we've got them in, and then when I get back to the office, I just put them into the system, and you scan every barcode, and yeah, you've got your site layout. I think it's brilliant. The SolarEdge system is like the best of the best, in my opinion. It's not cheap, but you get what you pay for. So I touched on this at the very start of the video, and something that we were very surprised to find with this job is that with it being a brand spanking new house, you would assume that it would pass its structural test. Now, the reason this property needed a structural is because of the roof shape, and so it requires a structural survey according to the MCS guidelines. So this customer paid in advance for a structural survey. We rightly or wrongly assumed it would come back fine, and it didn't. It failed, and it's a brand spanking new house. And in fact, the structural engineer did say that he was shocked at how small the trusses were. So we had to get it strengthened. We couldn't get hold of a joiner or anyone. They were all, you know, that old chestnut, I'm busy till Christmas and all that. I mean, it's nice if you can get it. But yeah, we couldn't get a joiner in time, so we did it ourselves. The structural engineer provided all of the calculations and provided all of the guidelines on what we needed to do, which we followed to the letter, including the distances between the nuts and bolts. We ordered some fantastic bolts from a guy who's actually recently invented them, and you can see the bolts were fantastic. They have like little spikes on the sort of nut washer, and as you tighten the nut, the spikes just pull into the wood. So actually we strengthened, I think it was about 17 beams or something like that. And the structure engineer came along, checked it all, and believe it or not, he actually said he's never seen a job done so well. So, you know, that's the thing with Alps Electrical. We could turn our hands to anything, but whatever needs to be done just needs to be done. You just have to get on with it, don't you? But that did come as a bit of a shock to us all, including the customer, that the roof would fail. And it is a lesson that you've really got to follow the MCS regulations. You know, a regular truss roof, dual pitch. Our system does all the calculations itself, but when you've got this sort of shaped roof, then, you know, you've got to get it checked. And we asked the structural engineer who did the report for us, you know, what actually would have happened to this roof potentially if we'd have left it. And he said, I can guarantee that, especially in the snow and things like that, when there's more weight on the roof, that it would have bored and potentially gave way over time. So that's a terrifying thought, and is why that we always do everything absolutely by the book. So this customer can now obviously sleep soundly knowing that the panels are not going to come crashing down on their heads, which is a good thing. So yeah, we've had our work cut out with this one, with the issues with not getting the Powerwall and the structural and everything like that. So we're quite excited to get back today and get on with and putting the Powerwall in and getting the system finished for these guys. And so let's go into the garage and take a look at what is there and what needs to happen now. So we're in the garage here, and this is obviously where all the components are going, and Brad's just fitting the Tesla gateway there that we left some space for. So when we were here a couple of weeks ago, obviously we installed the SolarEdge inverter here, which is such a nice small unit, like for 5 kilowatts. Usually the sort of, you know, other units might be like this big, at least twice the size. So it's a really nice, neat little unit. So yeah, the gateway's going there. This is the generation meter. If you just stand aside a little bit, Brad, for me, thanks, mate. This is the generation meter here. We've got our solar AC isolator, that's obviously for the inverter. And then inside this little junction box is the solar Modbus meter, which is a necessary component. It's basically just, it's like a CT clamp, but it's sort of digital, so that reads the import and export. We've got the DC isolator for the array, so we've only got one string, obviously, for all 12 panels, because they've all got optimizers underneath. So yeah, currently the inverter is fed from the consumer unit here, and now we're here to put the gateway in. We're going to pull that feed out of there, and that's going to be fed from the gateway instead. The main tails, the main meter tails that are going into this, we somehow are going to take them out of here. We're not sure where yet. We've got to put a Henley block somewhere, and then we're going to extend them into here, back to another Henley block, which will then go back to this house consumer unit. And then off our Henley block, we're also going to put a small consumer unit here on this side, which is going to feed both of our EV chargers. So yeah, the Powerwall, we've left a nice space here, and that's where this is going. So we're going to start getting that mounted shortly, and then we can get the power off and start getting all the wiring done, which we'll show you a little bit more of as we go. Okay, so we're getting there. It's took a little bit of doing, to be honest. There's a lot of rejigging and things we've had to change around. Obviously, we've now installed our smaller consumer unit here, which is feeding both of the EV chargers. We've put a new feed into the existing charger that the customer used to have on the other side of the wall. We've moved that. We've also obviously put the Henley block in, and we've split the meter tails. We managed to get a good pull on the meter tails that were entering the main switch here. We've pulled them and we've taken them through and up into there, and then we've got a set of meter tails going from the Henley block supplying our small garage consumer unit here, our two-way, three-way consumer unit. And then we've got another set of meter tails that then run all the way down through the trunking and into the gateway. Effectively, we've just redirected the meter tails through the gateway and into the board. And then we've got our breakers in here as well. We've got the inverter for the solar, Powerwall, we've got the supply for our Modbus meter, and then we've got the surge protection. So basically all like what we've had to do is like pull the inverter supply back, because it was in there, if you remember. That's now in there. The Powerwall supply is also in there. And then we've got CTs everywhere. We've got 5 CTs, would you believe? We've got 2 for the Zappi. We've got 1 for the customer's existing project EV unit. We've got 1 for the solar, and we've got 1 for the Tesla as well. So that's 1, 2, 3, 4, 5 CT clamps. Yeah, so yeah, we've just manipulated them in a certain way. So like I say, the solar cannot see the EV chargers when they're plugged in, and it will not supply them. So that's about it. Yeah, we're just having some lunch, and then we're gonna get the Powerwall on the wall. But we're pretty much wired ready for it. We've got the isolator ready to go, and we've got our 12 volt and ground, which is this one, and that comes from just up here. So then we've got the communications cable that runs from there, and that runs to the Powerwall as well. And then obviously the 6mm cable from the isolator. So we're there or thereabouts. So yeah, all good. Okay, so hopefully you can hear me over the generator in the background behind me. I told you we were on a new build site. Literally that house over the road there is not finished yet. So I've been through this before in another video, but I thought I'd go through it again in case you haven't seen that one. But anyone who's installing a My Energy Zappi along with solar, you can, wire it in a certain way in order to avoid the solar from seeing the car. And the reason you would do that is because tariffs such as Octopus Intelligent Go, by contract you're expected to leave it on Eco Plus setting, and they can initiate a charge as and when they can offer cheap energy. It used to be just 11:30 at night till 5:30 in the morning, and now it can be any time. It's always cheap at that time, but it could also be cheap at 2 o'clock in the afternoon. So the idea is you just leave your car plugged in on Eco Plus. As soon as you get home, you plug it in, and they will just initiate a cheap charge, and it'll send charge to the car. If you don't wire it in a certain way, like we have, charger switches on, but the solar sees that there's a load there that needs supply, and it's got 100% battery or whatever, or it's generating energy, and it will send it to the vehicle. So that's 7 pence that you could have been buying your energy in for, you're not actually using it basically. You're using your solar, which you could be exporting at 15 pence. So that's why you don't want the solar to see the EV. All right, and it's the same as well, like if you want to force discharge your batteries, which a lot of our customers do. If you're on Octopus Intelligent Go, for example, you could force discharge your battery at 9 p.m. at night or 10 p.m. Just before the cheap period starts again. You could say if you had 100%, if like this customer has a 13.5 kilowatt hour battery, they might want to discharge 10 kilowatt hours of it back to the grid at 15 pence. I know that's not mega bucks, but over a year, if you're doing that a lot of times, it does add up and it will reduce your payback period. What you don't want is to force discharge it and it just goes straight into the car. You want it to go back to the grid, hence why you need to separate the two. So there's a couple of things you need to do. You need to obviously have the EVs separated from your board. So you split the tails into a Henley block and the EVs are supplied separately. The other thing you need to do is you always have one CT coming from the Zappi, which is automatically in CT1, and that's designated to the grid. So that's monitoring everything in the house, what's going in and what's going out load wise. And the other thing you need to do is add a second CT to the Zappi, which goes into CT2, and you designate that solar and battery, or solar or battery only, depending on what you've got. In this case, it's solar and battery. I've already tested, CT1 is fine. So basically you go down to other settings, you go down to installer settings, and you just all the zeros for your password. CT config you go to, down to CT2, and then you go through till you find gen and battery. Sorry, it's not solar and battery, it's gen and battery. So that's CT2 now allocated as gen and battery. And then go to supply grid, down to network, down to battery, and change it to avoid drain. So that's those set now. So what I need to do is check. When at the minute I've got the solar off, there's no DC supply there. So at the moment it says waiting for surplus because it's set to Eco Plus mode. So it's waiting for export, it's waiting to see export, it's not seeing any, hence why, because the car's plugged in, so it's not sending anything. I'm going to now turn the solar on, and I want it to stay on waiting for surplus because it's still not seeing the solar, all right? So that's what I'm going to hope to see, and then I know that my CT2 is doing what it needs to do. There you go. So as you can see, the Zappi is still waiting for surplus despite the fact that the solar is on and producing. We're just producing a small amount of energy there through the panels because it's a really dull day. And as you can see, it's dropped to about 0.2 kilowatts, 0.1. It's dropping all the time because obviously they're using about 0.7 in the house. So that energy, it's seeing that energy going out, but the solar's not seeing the EV. So that's the important thing. It's not charging the vehicle, even though there's a little bit of export there. If I set that to fast mode now, it would just immediately charge from the grid. So far so good. That all looks like it's working as planned. Okay guys, so that is the end of this job. We've just finished, we've just commissioned everything and everything's working, so that's a bonus. We've got a very happy customer just behind the camera here who's eagerly awaiting to see how the system operates in the event of a power cut. So we will simulate a test in a second. I'll just quickly go over everything that we've done. Obviously we've added this consumer unit here for the two EVs that supply in the Zappi that we added, and the Project EV, which is original, that was added by the builders. The consumer unit now is obviously being backed up from the Tesla gateway. This one isn't because the Tesla gateway can't see it, so it's just literally backing up the house and the solar and everything like that. We've obviously added, we've got the inverter, which we've done a couple of weeks ago, and we've just put the Powerwall in, which has got about 28% in it, something like that at the minute. And in the gateway, we've got our circuit breakers, RCBOs, got the main switch, you've got your main fuse, and then this main switch supplies this row here. So we've got the solar on this 32 amp, and we've got the Powerwall supplied by this one. We've got a 6 amp supplying the Modbus meter, which is for the inverter, and then we've got the surge supply as well. So yeah, lovely looking bit of kit, it really is. And obviously we've got the SolarEdge as well. So these two brands together are pretty much, you know, the creme de la creme of the solar world. So a really quality system that hopefully the customer's going to be very happy with, and generating lots of electricity and storing it in this fantastic battery that obviously can be added to. So we'll try, we'll do a power cut. We'll simulate a power cut, should I say, and I can do that just in the app here. I'll record my screen. Right, so at the minute, it's not showing any solar production at the minute because there literally isn't any. It's such a dull day, and it'll only display that if there's over 100 watts, and we're producing about a whopping 24 watts at the minute. So obviously not seeing that. The battery's at 29%, so we can simulate a backup test. So obviously we've got the lights on in the garage at the minute, so we'll see if they flicker or not. But one thing to note about this is, depending on how much capacity is in the battery at the time of the outage, will depend how quick it changes from grid to backup. And also it depends if you've got heavy loads on at the time. It might take a little bit longer, and by longer I mean like a second, but hopefully we won't even see the lights flicker. So here we go, backup test, begin backup test. That's it, off grid. So there was did anyone notice a flicker? I didn't notice a flicker. So that's it, everything's up and running, everything's working just as it should, and it's been a great job. Obviously we've had our challenges, as I mentioned earlier, with the roof that needed some extra supports putting in there, and then we're obviously doing it in 2 stages. Usually we'd do everything all at once, but because the battery wasn't available, we've done it in 2 stages, which has worked out a treat. So all done, all happy in the end. So thank you for watching. If you've enjoyed this video, please don't forget to like and subscribe. We've got lots of other videos on our channel, and as always, it's really appreciated any comments, and thanks for watching. We'll see you on the next one.